Okay, Hannah has 24 pencils. She went to the store with her mom and bought 57 more pencils. How many total pencils does Hannah now have? In order to solve this problem, we are going to use the place value approach. The place value approach includes 1 unit, which equals 1, 1 long, which equals 10, and lastly, 1 flat, which equals 100. This helps us to remember that there are 10 units and 1 long, and 10 longs and 1 flat. So now, getting back to the problem, we know that Hannah started out with 24 pencils. We see that the 4 is in the ones place value. So this means 4 units. So let's get 4 units. 1, 2, 3, 4. Next we see the 2 is in the tens place value. So this means we need 2 longs. 1, 2. This means that 2 tens equal 20 and 4 units equal 4. So let's count it out. 10, 20, 21, 22, 23, 24. Next, Hannah goes to the store and buys 57 more pencils. So we're going to add 57. We're going to do the same thing we just did with 24. We see the 7 in the ones place, so let's collect 7 units. 1, 2, 3, 4, 5, 6, 7. And we also see the 5 is in the tens place. So we're going to need 5 longs. 1, 2, 3, 4, 5. Since 1 long equals 10, we're going to count the longs by 10. So let's see how many we have. 10, 20, 30, 40, 50. Plus 7 units, 51, 52, 53, 54, 55, 56, and 57. So in order to find out how many total pencils Hannah has, we're going to use our place value blocks. So we need to figure out 24 plus 57. So let's get started. Let's start with the ones place value. We need to count up all of the ones place value units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now we see we have 11 units. So we're going to put those to the side while we count out our longs. So we're just going to do the same thing but count by tens since 1 long equals 10. 10, 20, 30, 40, 50, 60, 70. So now we have 7 longs. So let's get back to our 1 units. Since we know 10 units equals 1 long, let's try to see if we can find 10 units and regroup it to get 1 long. So let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To make this easier, we're just going to substitute the 10 units for 1 long. So now we take 1 long and take away the 10 units. So now we have 1 unit left. So let's count up our total. 1 long equals 10. So we're going to count by tens. 10, 20, 30, 40, 50, 60, 70, 80, and 1 unit. So 81. We just found out that 24 plus 57 equals 81. This means that Hannah has a total of 81 pencils. Okay, so Paul went on a bike ride at 1 o'clock p.m. He rode his bike until 3:45 p.m. For how long did Paul ride his bike for? Okay, so in order to solve this problem, we are going to use the Make 60 approach. But a common misconception about the Make 60 approach is students don't realize that elapsed time is in base 60. They think that it's in base 10, just like regular math. So in order to make this more clear for them, we're going to get a regular clock and count all of the ticks within the clock. This will be easy for this child to see that we are using base 60. So let's get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. So now we know that we are doing elapsed time in base 60. So going back to the question, we're going to use our Make 60 chart. So we're going to put hours in the left-hand corner, minutes in the middle, and to track the time on the right. So since Paul started his bike ride at 1 o'clock p.m., we're going to put 1 in the hours spot, a colon, and 0, 0 for the minutes. This means Paul started riding his bike at 1 o'clock. Now that we know that 60 minutes equals 1 hour, we have to figure out how to get to 3:45. So let's make it simple and just start by adding 1 hour, which equals 60 minutes. So we're going to write plus 60 minutes in the right column. So since we know 60 minutes equals 1 hour, we know now we are at 2 o'clock. So we still need to keep going. So we're going to add another 60 minutes. And we're going to put the 3 in the hour column and 0, 0 in the middle column. So now we see that we have had 2 60 minutes, which equals 2 hours, and we have gotten to 3 o'clock. So all we have left to do is get to 3:45. So we're going to write 3 in the hours column and 45 in the minutes. So this means Paul stopped riding his bike at 3:45. So we see that all we have left over is 45 minutes. So we're going to see that we added 45 minutes. Now we have to find out the total time that's between 1 o'clock and 3:45. So luckily we can look at our time tracker column and just add up all the minutes. However, we're going to have to regroup them into hours. So we're going to write 60 plus 60 plus 45. So 0 plus 0 plus 5 equals 5, and 6 plus 6 plus 4 equals 60. So we see that Paul rode his bike for a total of 165 minutes. However, we need to convert our minutes into hours. So, looking back at the problem, we see we have 60 minutes, which equals 1 hour, and another 60 minutes, that equals 1 hour. So now we see we have 2 hours. And because there's not another 60 minutes, we know that we stopped at 2 hours. So we're going to write 2 hours. And all that we have left is 45 minutes. So by regrouping the 165 minutes into 2 hours and 45 minutes, we found out that Paul rode his bike from 1 o'clock to 3:45 for a total of 2 hours and 45 minutes.